Hi, today I would like to share a new adversarial data augmentation method for ASR models using AugMax-for-ASR. We know that deep learning methods have been found to be vulnerable against adversarial attacks, which can perturb the input to cause erroneous predictions. One promising way to defend against such attacks is adversarial training using adversarial data augmentation techniques, which means retraining the model on adversarial samples. So far in literature, a large number of adversarial data augmentation techniques have been proposed, but mainly for the image space, whereas for ASR, methods are very limited. In this work, we want to explore some ASR-specific adversarial data augmentations. Among existing works for adversarial attacks, one popular type is PGD attack. It uses the gradient information to perturb X in the direction that can maximize the loss function. However, it has been found that methods like PGD attack can generate hard samples, but it lacks diversity. This can be illustrated in a 2D feature space. Standard augmentations increase diversity of the training data by making some random transformations, as in the first figure. Whereas the PGD attack increases hardness, the generated samples tend to concentrate in the region that is hard to classify, in the second figure. Ideally, in order to achieve good model robustness, the augmented data should have both hardness and diversity, as in the third figure. And to this end, an image augmentation method called AugMax-for-ASR has been proved successful. Now the question is, can we do similar thing in the speech domain? The answer is yes. In this project, we developed AugMax-for-ASR to do this, and here I want to show some sample adversarial audios we generated. In the first sample, originally it sounds like this.
The colorist says, first of all, as my delicious.
And after augmentation, it sounds like this.
The colorist says, first of all, as my delicious pet.
So we see the voice sounds deeper and stronger. And then the second sample, originally,
they asserted with confidence and almost.
And after augmentation,
they asserted with confidence and almost with exultation.
This sounds like the voices added some noise. And the third sample, originally,
thought kills me that I am not thought.
After augmentation,
thought kills me that I am not thought. To leave love.
The voice now have a lot of echo effects. So from these examples, we can see that the samples can be augmented in different ways, and this increases diversity in the adversarial samples. So how do we achieve this? The high-level idea is an adversarial composition of random augmentations. Specifically, we have a set of random augmentation techniques for speech signals. For example, low-pass filters, adding noise, turning sounds up and down. And then for any input X, we have different augmentation trajectories. This figure shows 3 trajectories, X-log1, X-log2, and X-log3. For example, in the second trajectory, we randomly select a subset of operations, like adding noise and low-pass filters. This gives us X-log2. And finally, we do this for every trajectory. We want to combine these different trajectories through a weight sum of augmentations using the weights. And these weights are selected iteratively using gradient information to increase the ASR loss so that the augmented data is adversarial. Further, here are some evaluation results of AugMax-for-ASR on the library speech data. The metric we use are character error rate and word error rate. The pre-trained ASR model gives a higher error rate on adversarial data. Finally, to conclude, we developed AugMax-for-ASR. It provides an adversarial composition of random speech augmentations, and we found that AugMax-for-ASR is able to generate adversarial samples with very high diversity.